Hello everyone. So today's topic is morphology in digital image processing. So the morphology basically is the process where we use a morphological operator. There are different morphological operators like dilation, erosion, opening, closing, hit or miss, thickening, thinning, skeletonization. There are different types of morphological operator. By using this, we can change the shape or we can actually change the boundary around the image. We can grow the region around the image, we can shrink the region inside the image. So there are multiple application in that. If we want to remove some noise from the image, we can use one of the morphological operator in order to remove the noise, or you can say salt and pepper noise. We already seen the application of image enhancement, that is low pass median filtering. In that we have removed salt and pepper noise from the image. So there are multiple morphological operators we can use in order to uh, change the region around the image. So if you consider this image, this input image, and this is nothing but the output of the input image after applying some morphological operator. If these are nothing but the unwanted noise, we can remove the noise using morphological operators. If you consider the green, for examples, if you are considering green as a foreground and black as a background. Basically, in image processing, we consider ones, all ones. That is, image in the binary, all ones are actually representing a foreground. Zero represents background. So we can use a structuring element as an input image. A structuring element is also known as a kernel. By matching the foreground or a background, we can change the shape and the size of an image. In this input image, the input image, if you see the input image is very much bigger than the output one. Means the image has been shrinked by applying some morphological operator or a kernel on the input image. This is nothing but desired output. So application can be anything. So depending upon the application, you will use the morphological operators. Okay. There are different types of morphological operators like dilation to grow image regions. Means if you consider this as an input image, this is nothing but the dotted lines are nothing but the boundary of an image. You can expand the boundary or the regions in the image. If you consider this is the boundary of an image, you have shrinked the image by using erosion. So you will erode the input image with a structuring element. You will dilate the uh, input image with a structuring element. Dilation is nothing but the growing image region. Erosion is nothing but erosion of an input image, that is a shrinking of an image region. Then opening, we can open, that is nothing but this. If you consider this, all these corners of this input image, it has been opened using opening morphological operator. So structure removal of image region in a boundary pixel. Closing means you are adding some extra part to the image. Structure filling, you can say, in an image region boundary pixels. Hit or miss transform, where you have a structuring element which is made up of foreground as well background pixel, that is 1 and 0. It is a combination. Now in many morphological operator, you can say the maximum structuring element we use, which is made up of all ones. Normally all ones or don't care. So if we consider the hit and miss transform, in a hit and miss transform, we use a structuring element which is made up of both background and foreground pixel. One represents foreground and zero represents a background. Okay. Then multiple application, you can say thinning, thickening, skeletonization. It is used to find a skeletons of a binary image. Okay. And thickening is nothing but, if you consider dilation and thickening, it is structured dilation using image pattern matching. Sorry. So we are going to start from a new morphological operator, that is dilation. Now dilation basically we use to enlarge the boundary regions of a foreground pixel, where we have already studied foreground is nothing but ones. Now areas of a foreground pixel grow in a size while holes within those regions become smaller. If you consider hole, that is nothing but the background represented by your 0, then we can actually decrease the size of a 0, that is background image, by using a structuring element. If you consider a structuring element, this is nothing but the structuring element we already studied in high pass filtering, low pass filtering. Now if you consider a structuring element, that is a 3 by 3 square, in order to modify the desired in order to modify to the desired output, we are considering this is as a center pixel. So we are keeping in mind that we will place our structuring element or kernel in a such a way that we can target the center pixel, or you can say the coordinate will be 0 oblique 0, because if you consider the structuring element -1 0 1 on x axis, -1 0 and 1 on a y axis, the set of coordinates will be -1, that is -1 -1, -1 0, -1 1. Again, for this neighborhood of this center pixel will be 0 -1 0 0 0 1, then 1 -1 1 0 and 1 1. These are nothing but set of coordinates. So common names for the dilation is to grow the image, to expand the image, or dilate the image. For example, now if we are considering a structuring element, a 3 by 3 structuring element, suppose if I want to dilate the input image, it is nothing but the input image which is made up of background pixels 0 and 1. Now if I want to grow the image, I need to place these masks for each and every pixel. Suppose I want to target the first pixel. Okay, I'm placing this. I have placed my mask on the target image. Now, in order to change the pixel value, we know in a input background there is 0 at the middle. You will see if the coefficient of a structuring element are matching with the input image. If you consider a structuring element as a B and a input image as a A, you need to actually match the pixel of B with the pixel of A. Now we know inside the input image, we know there is 0. We'll consider each and every pixel of input image A, and we will place the mask in order to change the pixel value. If the application is dilation, so we will shift a mask to a right, row by row, column by column. If I want to change, if I want to actually dilate the first pixel of an input image, I will place a mask in such a way that if you're considering there are no any pixel, means you will pad this input image with all zeros, so 0 0 0 0 0. So there, if you consider the structuring element in input image 1 0 1 0, so behind the 1 there is a 0, behind the 1 there is 0, behind the 1 there is a 0 1 0 1 0 1 0 1 0 1 0. So any of the coordinates in the structuring element is not matching with the input pixel, so we will keep it as a background pixel, that is 0 in the output. This is nothing but a background 0. then we will go to the next step, that is we will shift the mask to the right, like this. Suppose we have kept our structuring element or a mask on that particular image. If you consider this pixel, the output desired is 0 only. Why? No, there is no any matching between your structuring element and your input image. 1 0 1 0 1 0 1 0 1 0, everywhere 1 0. There is no any match between the structuring element and the background image. So we'll keep it as a background image 0. Same next pixel also, you will find no matching between structuring element and input image. But once you hit the next pixel, then you will find there is a match. In the ninth box of your structuring element, if you consider 1 2 3 4 5 6 7 8 9, in the 9 box you will find there is a matching, that is 1. Means you are superimposing your structuring element with the input image. After superimposing of your structuring element with the input image, if you find a match between structuring element and input image, you will replace this target pixel to the foreground, that is 1 that we have already set here in our output. Similarly, if you shift your mask to the right side for the next pixel, there are two match, 1 2. Any of the pixel is matching with the input image, you will replace the target pixel to the foreground, that is 1. You need at least one match in the processing. For the next one, again 3 matches below this row you have 3 matches, that is 1 2 3. Okay, then again you will shift to the right side, you have a 2 match, so you will replace this target pixel as a 1. Okay, again if you shift to the right, you will have again 1 match, that is why your target pixel will be set to the foreground pixel 1. Similarly, if you shift here, no, you will not find any match, because now you are out of the foreground boundary. If you consider 0 0 0 in the input image, 0 0 0 0 0 all over 0, and if you have any conflict of your structuring element pixel with the input pixel, you find there is a no match. So I will actually replace this target pixel, that is this, as background 0. Similarly for this, again you will find there is no any match in between your structuring element and the input image. Again you will replace this pixel to the background image. Sorry. Similarly, if you find the second row, in the second row I need to again consider the structuring element. I will place my structuring element like this. Okay, if you find 1, if you're considering 0 padded image, behind 1 there is 0, no match. Behind 1 there is 0, behind 1 there is a 0, behind 1 there is a 0, and behind 1 there is a 0. All over you will find there is no any match, so you will replace this target pixel as 0. Again, you will shift to the right side. You will see no match 10 10 10 10 10 all over 10. So no match again. And the output image you will find, you will replace the target pixel with a background image, or you will keep a background as it is, that is 0. But when you go for the next pixel, there is a match again. In the ninth box you will find a match. So because of any or minimum for any match, you will replace this target pixel to the foreground image 1. So that is why 1 here, 1 for this pixel. So there are total 1 2 3 match. So we will replace this target pixel with 1, that is this, and without image. So this is the concept of dilation. And if you look at the actual output image, you will able to see, suppose if you are considering this small image inside this input image, we will check for that. Okay, if you consider, sorry, your input image, in this input image your foreground starts from this row. So I will actually check for this row. Okay, so I will start from this pixel. If I place a mask like this, okay, you will find there is no match 10 10 10 10 10 all over 10. So I will replace it with 0 0 0. So but when you hit, means at the output, if I want to check this, why it is the foreground pixel. Okay, 1 2 3 4 5 and sixth column, 1 2 3 4 5 and sixth column. Okay, okay, there is a match, there is a match. That is why this pixel has been changed to the foreground pixel. Again, if I shift, there are 3 matches. So again I will shift to this. If I shift to this, yes, there are 1 2 3 matches. Again I will shift to this. So that is why the target pixel will be replaced to 1. Again for, yes, there are 2 matches, so it will be replaced by foreground pixel. And for a lower row there are 1 match, so this target pixel will be replaced as foreground. Similarly for the below, yes, there are 1 match, that is why this pixel will be replaced by 1. Okay, for this pixel there are 2 match, so I will replace this as for to the foreground pixel 1. Again, if I shift, there is 1 match, so 1 means you are able to grow the image area around the foreground boundary. If you represent 1 as a foreground, 0 as a background, you will see there is a region growing in the desired output. This was actually input image, and after dilation you have found the new image that has been grown through a structuring element B. If B is a structuring element, A is the input image. So basically in a dilation So in a dilation, we can consider dilation of a dark blue square by a disk. Disk represents a structuring element or a kernel, and your light blue square, oh sorry, a dilation of a dark blue square, dilation of a dark blue square by a disk resulting in light blue square. It has been dilated. Means if you have the dark blue square, this dark blue square as an input image, you have grown your dark blue square to the new boundary, that is up to the light blue square. It has been grown to a new size of your square, and because of the circle only you are getting this smooth curve along the corners. Okay, so the structuring element, the shape of a structuring element is a circle. That is why you are getting this. Okay. Now, a binary image is viewed in a mathematical morphology as a subset of Euclidean space RD or integer grid ZD. We have already considered the structuring element, which is also made up of your all ones, that is the binary one, and we were dealing with the input image, which is made up of 0 and 1, combination of zeros and 1. So we need to consider the grid always, the binary grid. If E is your Euclidean space or integer grid, a binary image in a E means A relates to the E, and structuring element B is a subset of RD, that is Euclidean space RD. So each and every pixel are in a Euclidean space, that is the universe of a binary grid, you can say. So dilation is represented by this symbol. So if I want to dilate A using B, if B is a structuring element, that is B relates to the, or B belongs to, that is small b belongs to B, capital B. If B is a grid, out of the entire grid I am taking this as a 3 by 3, 5 by 5, 25 by 25, whatever the size of a structuring element I am using in order to, if I want to grow the area in a larger perspective, I will go for the 25 by 25 size of it. It can be anything, the application can be anything, this circle size can be anything in order to grow the region. Sorry, if I will select the larger circle, then I will be able to grow the area in a larger extent. Okay, so the dilation of A by B is defined by this symbol. So A dilated by B represented by union, where this is a translation of A by B. That is, translation means transformation of A after applying the B as a structuring element. If B belongs to capital B, where B is a structuring element. So this is normal binary morphology. The next type is erosion. Now, erosion, it erodes away the boundary of a region of foreground pixel. Means it removes a white pixel. It removes some foreground from the image. Means it will shrink the image. Okay. Now, the areas of a foreground pixel shrink in a size, and holes within those areas become larger. In dilation, on the contrary, you were having the areas of foreground pixel grow in a size. Here, the areas of foreground pixel shrink in a size. Okay, and sorry, holes within those area become larger in erosion, and holes within those regions become smaller in dilation. Holes are nothing but zeros, and foreground pixel are nothing but 1. Again, we are considering the same 3 by 3 square. in this 3 by 3 square we have a set of coordinates. By using these coordinates we can actually target the pixel, that is the input pixel. We are considering two input image again, same your structuring element as well as the binary image. So the erosion is also known as shrinking of an image to reduce the size of an image. Erode. Again, how we use, if you look this, the input image, you will find the output image has been shrinked. Okay, how? Again, you will place the structuring element on each and every pixel. Now the criteria for the erosion is you need to match the all the coordinates of a structuring element. You have to match all the from 1 से लेके 9 सारे के सारे मैच होने चाहिए, सारे के सारे pixels has to be matched with your input image. Then only you will replace this one to the background, or you will keep the target pixel as a background, that is 0. So how will we do it? So for example, this, we're taking this example. Suppose this is your structuring element. Okay, I will place on the target pixel, that is the first pixel. Okay, uh, okay, this is enough for a consideration. Again, you will pad again. If there are no any, means you will consider as a 0 as a background, because the image is nothing but only foreground. It provides you the information. So 1 0 1 0 1 0 1 0 1 0 1 0, there is no match, nothing. Now for erosion you need to match the all coordinates. Yes, if I place over here, no, only 1 2 3 4 coefficients are matching with the input image. But to match the entire, means in order to match all the coefficients of a structuring element with the input image, I need to put in this manner. So that is why I will be able to match the entire coordinates only if I keep like this. So this target pixel I will be keep it as 1 for any of the foreground. If I find any of the mismatch, you will make it to the 0. That is why the 0 here. Okay, for this only 1 2 3 4 5 matches. No, I need all 9 matches. Okay, I will be able to get all 9 matches only for this pixel. Okay, then for this pixel, that is this. Okay, and for this pixel, that is this. Now if you go for the next pixel, no, there is a mismatch, so no. So you will set your target pixel to the background pixel 0. Okay, now again, yes, all the pixels are matching, all the pixels are coincide with the input image, and all the pixels are matching with the input image. The structuring element, the coefficient of structuring element are matching with input image, all ones, 1 1 1 1 1 1 1 1. So that is why again this pixel is nothing but this one. Similarly for this, you consider if you shift to the left, there are two mismatches. So same 0 means you need to match all the pixels of structuring element with the input image. If you shift to this, there are two mismatches, sorry. Okay, two mismatches, so you will replace it with 0. If you go for no, I won't be able to match all the pixels. So this target pixel will be set to 0. Similarly for this, no, I cannot accommodate my structuring element for this smaller image. No, so it will be set to 0. This is nothing but illusion. You need to match all the pixels value with a input image. Okay, so if you consider this input image and this, you have eroded your input image by using structuring element B. If A is the input image, you have eroded your input image A with a structuring element B. This shrinkage, you can say. Mhm. So this is basically the erosion. That is one of the morphological operator you are using in a digital image processing. Same example. Now the erosion is represented by this symbol. Erosion of A by B, where B belongs to B. Okay, and A minus B, where minus B means you are eroding. That is why you're considering minus B. Yeah, yeah. As an intersection, we were dealing with the union in a dilation. Union. Here you are considering the perfect match. Intersection area. That is it. Now the erosion of a dark blue square by a disk, the resulting in a light blue square. So you have eroded the dark blue square to the light blue square with a structuring element, the circle element. This, okay. If E be the Euclidean space or integer, A is a binary image in E. A relates to E, that is E is a Euclidean space. The erosion of a binary image A by structural element B is defined as Z, that is Z, belongs to E, that is grid, binary grid belongs to E. E is a Euclidean space, and BZ is nothing but a translation of P after using Z, or you can say uh, BZ subset of A, where BZ is a translation of B by the vector Z. That is BZ is nothing but B plus Z, where B belongs to capital B. That is, when the structuring element B has a center and center is located on the origin A, then the erosion of A by B can be understood as locus of point rest. So because of this center only, you are getting the square area. If you are considering a dilation, you are considering the smooth curve along the way. Now here you are dealing with the center position. That is why the target pixel, you can see target pixel of a structure. That is why you are able to erode the image in that manner. Okay, so this were the types of morphological operator. We will study the next morphological operator in the next video. These are nothing but opening, closing, hit or miss transform. So out of all the morphological operator you have in your syllabus is, um, you have a dilation, erosion, opening, closing, hit or miss transform. So we will meet in the next video. Thank you.